Okay, so we now move on to the second technique of integration, which is trigonometric substitution. So as you can see in the in the three different formulas, so we're going to get its corresponding trigonometric substitution from the particular radical format going into its corresponding trigonometric substitution. Okay, so again, the aim of your advanced techniques is usually to eliminate the complicated terms such as the radical expressions. So for example, um, usually your trigonometric substitution is another way of solving your inverse trigonometric functions. So as you can see in the first formula, so that's square root of a squared minus u squared. So going back to our inverse trigonometric functions, so that's du all over square root of a squared minus u squared. So for example, you don't achieve this format, but you achieve the radical expression format, this one. So instead of using the inverse trigonometric functions, so we're going to use the advanced technique, which is your trigonometric substitution. So notice that the corresponding trig sub is also in the sine format because the answer for this one is inverse sine, di ba? So arc sine u over a plus c. So in the second formula, so this is coming from the format of du all over a squared plus u squared. So for example, so kung sa bali-bali, you cannot achieve this format, but we have this format square root of a squared plus u squared. So its corresponding trigonometric substitution is u is equal to a tangent theta. So again, notice that it's familiar because the answer for your inverse trigonometric integrals is arc tangent, diba? 1 over a arc tangent u over a plus c, diba? And then lastly is your u squared minus a squared. So again, if you don't achieve the format in the inverse trigonometric integrals, so muna siyang format, diba? I mean, dito siya u squared. It's only u square root of u squared minus a squared. But for example, you don't have this format, but you have this format. So we can utilize the trig sub technique. So we can use the formula of u is equal to a secant theta. So notice the answer for your inverse trigonometric integrals is a 1 over a arc secant u over a plus c. So notice na nagmukha mo na siya sa mga different formulas from your inverse trigonometric integrals. So of course, you can also use the triangle, the right triangle in deriving the formula. So for example, this one is theta. So a sine u, diba? So u. But then let's say this is our a. So that's for the sine function, diba? So notice in the first formula, this one, first formula. So if you draw the right triangle for that particular formula, so sine opposite over the hypotenuse. So getting the third side, the other side, baliday. So let's try to fix this one first. So this will be your a, then this will be your u function. Baliday siya. So a ni siya, then this will be the u function. So opposite side is the u, the hypotenuse is a. So if you take the other side, that will be a squared through Pythagorean theorem, a squared minus u squared. So diba, murag the same format on this side. So diara siya gikan sa inyong triangle. So same goes for the other formula sad. So for example, we have your tangent. So opposite side is u, then adjacent side is a. So opposite over adjacent. So meaning the hypotenuse is the sum of the squares of the two sides according to Pythagorean theorem. So that will be a squared plus u squared. So notice that this one is the formula here. So later on, we'll be utilizing these triangles in getting the different formats of your integrals. So lastly, a second, that will be hypotenuse over the adjacent side. So this will be u, this will be a theta. So hypotenuse all over the adjacent side. So meaning this one is u squared minus a squared. So 1, then 2, then 3. Now 1, 2, 3. Okay. So let's try to solve some problems for you to appreciate the formulas being presented. So again, the aim of this technique is, for example, you can't achieve the format of the given inverse trigonometric functions. So we have another option, which is your trigonometric substitution. So muna siya akong i-discuss later. So for example, so let's go to the different examples. So we're going to discuss 6 examples. Okay, so let's go to the first one. So nag-record ko. I'm using OBS. Okay, so again, if you're going to look at the first example, so you might think that you can solve this one using the inverse trigonometric formulas. So as you can see, we have the integral of 1 over x squared times square root of 16 minus x squared with respect to x. So notice if we try to look at the format of your inverse trigonometric functions, that will be du all over the square root of a squared minus u squared. So notice that the radical expression can be achieved by the inverse trigonometric functions, diba? But the x squared is an extra term in your denominator which is not found in the formula for your inverse trig, diba? Wala siya, diba? So this is the time that we can utilize the technique of your trigonometric substitution. So in doing so, let's try to change color first. So again, as per formula, square root of a squared minus u squared is equal to u. So ato lang arrow. U is equal to a sine theta. Alright? Sakto, diba? So let's try to identify first our a and our u parameters. So coming from the format, so this is our a squared, this is our u squared, diba? So a squared is equal to 16. Getting the square root, we have a is equal to 4. Alright? So next is our u squared parameter. So u squared is equal to x squared. The square root of this one is u is equal to x. Okay. So by formula, so utilizing the formula, so this one, so this is x is equal to 4 sine theta. Again, so this one is coming from this particular formula. So after determining the a, the u, and the formula. So next step is we're going to draw a right triangle first. Okay. Then we're going to assign the different sides of the sine function. So this one is theta. So again, if we can rearrange the formula, that will be sine theta is equal to x all over 4. So x will be the opposite side, and then 4 will be the hypotenuse. So again, as per Pythagorean theorem, so this will be the third side will become 4 squared minus x squared, diba? That will be 16 minus x squared. Okay, so notice that 16 minus x squared is present in the equation also. Same here. Okay, so next step is since the technique is called substitution, diba? Notice that we're going to use substitution. And also notice that our formula is in the theta condition. Diba? X is equal to 4 sine theta. So we should expect that our format should be in theta also. So all of the transformation will be on the theta parameter. So how do we do this? So notice that we have this formula x is equal to 4 sine theta. So notice that we can replace x here, di ba? The x squared. So this becomes 16 sine squared theta. So how about your kaning square root of 16 minus x squared? So 16 minus x squared can be replaced using the triangle here presented below. And we're going to pair this one up. We're going to pair the radical with a certain value of the constant. So dili variable na itong i-pair, but we're going to pair your square root of 16 minus x squared with a constant. So since we determined that the pair of your square root of 16 is 4, so we're going to determine the function required for the pair up. So the easy function for this pair up is cosine function, di ba? Adjacent side all over the hypotenuse. So writing it down, cosine theta is equal to adjacent side 16 minus x squared all over 4. So isolating your square root of 16 minus x squared. So we have 4 cosine theta is equal to the square root of 16 minus x squared. So notice that this term here is muna siya ang atoang square root of 16 minus x squared. So notice this term is also in terms of theta na, di ba? 4 cosine theta, the x earlier is 4 sine theta. So puro ta mga theta, di ba? Theta u parameter. So ganina, the a and the u parameter is just a process in determining the different values for your a and your u for the formula. So again, this one is the formula. So that's why we convert everything into the theta aspect, but delete the u aspect. So what's left for us to determine? So notice that we can replace x squared. We can replace square root of 16 minus x squared. So what's left for us to do is to replace dx. So determining dx, so of course from the formula. So that's always from the formula. You derive the formula. So x, this becomes dx. So on the right side, so that's 4 cosine theta, d theta. And this is the formula here. All right. So we can now replace every term in your parameter, in your integrand. So let's try to change color again. So the integral, so again, dx in the numerator, that's 4 cosine theta d theta. Denominator, starting with x squared, so that will be, so again, this one is, ano siya, di ba? That will be 4 sine theta squared. And then lastly is your d theta. I mean your square root of 16 minus x squared, which is this one. So we have 4 cosine theta. So notice that we can cancel out 4 cosine theta. Cancel out 4 cosine theta. And what's left in the equation is you have d theta all over 4 sine theta squared. Or if we try to simplify this one, this becomes d theta all over 16 sine squared theta. Okay, so notice that we can further simplify this one by extracting the constant sign. So 1 over 16. So we have d theta all over sine squared theta. So I think this one is, if you try to recall your trigonometric integrals, this one is a formula already, because if you try to reformat this one, this becomes, so 1 over 16. This becomes cosecant squared theta d theta. So I think we have a formula for this one, cosecant squared theta. And I think that's, sakto ba? Nabatay ko? So I think the answer for this one is negative cotangent, di ba? So you have negative 16 cotangent theta plus c. So of course, how do you replace your cotangent theta back to its original condition? So we go back to the triangle. So again, notice that your function now is cotangent. So cotangent function in terms of its definition, that's adjacent side all over the hypotenuse. So that's 16 square root of 16 minus x squared all over the x parameter. So the answer is negative 1 over 16. So times the square root of 16 minus x squared all over, so di siya over 4 but over x. So over x, then plus c. So the final answer is, so I'm going to write it on the upper right. So negative square root of 16 minus x squared all over 16x plus c. So that's how you solve this problem. So assigning variables first, then you get using the formula. Then after using the formula is we're going to create a right triangle, then identify the different parts. And then from that part, we're going to eliminate the radical expression using a certain trigonometric function. So in this case, we have used the cosine function. So don't forget that when you pair up the radical expression, so you always pair it up with the constant, not the x parameter. So after determining the, the possible trigonometric substitution for the radical expression, so we determine the derivative of the formula. Or para di mo malangay, so after determining the formula, so just derive it also immediately right after determining the formula. Then after deriving, then you create the right triangle. Okay, so do you have questions for the first formula? I mean, for the first example. Sige. Ang sa last step, kaya nawala siya because we transform it back to the kuan, the kanayang counterpart na mga real values. So, again, going back to the triangle, ano siya dire? So, if we try to, so cotangent theta is equal to adjacent side over hypotenuse, di ba? I mean, over opposite side eh. So, opposite side of the theta function, so this one is the square root of 16. Then, opposite side is the x parameter. So, cotangent theta is equivalent to square root of 16 minus x squared all over x. So, muna siya dire. Diba? So, sakto ba? So, sakto na ba? Okay, magnawa mo itong nangutan na. Sige. Okay, so let's proceed to the next example. So this time is we have the integral of 1 over x times the square root of 9 plus x squared. So again, if we try to look at the formula, so again, it's impossible for us to reformat it in the inverse trig function, which is du all over a squared plus u squared. So this one is a squared plus u squared, but it's being enclosed by the radical expression. But looking at the inverse trig formula, there's no radical expression, diba? So you cannot utilize this formula. So since you cannot utilize the inverse trig, so what we're going to do is we're going to use the trigonometric substitution. So again, as per formula, this is the square root of a squared plus u squared. It's equivalent to u is equal to a tangent theta. Alright, so determine first the different values of your a and your u squared. So this one is a squared, this one is u squared. So a squared is equal to 9, then a is 3. Then your u squared is x squared, then your u is x variable. So we now utilize the formula. So the formula is x is equal to 3 tangent theta. Okay. So if you want to derive it immediately, so it's also correct. So let's try deriving this one. So dx, then we have 3. So again, the derivative of your tangent is secant squared. Secant squared theta d theta. So notice that we can replace your dx here with 3 secant squared theta d theta. We can replace the value of x here with 3 tangent theta. So what's left for us to replace is the square root function, which is the square root of 9 plus x squared. So again, we draw a right triangle. So this will be our theta. So again, since we are utilizing the tangent function as per the formula, so we're going to have the opposite side and the adjacent side. So opposite side is the x parameter. So for those of you who don't know why it's x, so if we try to isolate the tangent function, this is tangent theta is equal to x all over 3. Diba? As per definition, this is your opposite side. This is your adjacent side of the angle. So this is 3. So as per Pythagorean theorem, this is 9 minus x squared. So the sum of the squares of the two sides. So 3 squared is 9. So plus din siya, plus. So 3 squared plus x squared, that's the square root of 9 plus x squared. So again, since we are trying to eliminate the radical expression, so this one, we're going to eliminate this one. So we're going to pair it up with the constant. So constant. So upon pairing up with the constant, so we try to determine the corresponding trigonometric function for the pair up. So the simple format for this one is the cosine function. So cosine theta is equivalent to adjacent side, that's 3. And then the hypotenuse is 9 plus x squared. So again, since we are trying to isolate or we're trying to replace the square root function, so we have to isolate the square root function. 9 plus x squared is equivalent to 3 cosine theta. Or we can represent it also as 3 secant theta. Sakto ba? 1 over cosine is secant. Secant, secant. So it depends on how you pronounce the trigonometric function. So with this, we can say that we can now replace your square root of 9 plus x squared with this one here. So notice also that every replaced term is in terms of theta. So you have 3 tangent theta for the x parameter. We have 3 secant squared theta d theta. We have 3 secant theta. Alright, so replacing is we have, again starting with the x, that's 3 secant squared theta d theta. Then the x parameter is 3 tangent theta. Then the square root function, the square root of 9 plus x squared is 3 secant theta. Alright, so again, dx is this one. The x parameter is this one. Then the square root of 9 plus x squared is this one. So I think we covered every substitution process. So how do we simplify this one now? So simplifying first by eliminating the 3, eliminating 1 secant in the numerator, eliminating the secant theta in the denominator. So what's left in the equation is the integral of secant squared, I mean secant theta d theta all over 3 tangent theta. Okay, so if we try to isolate 1/3, so we have secant theta d theta all over the tangent theta. So I think with this we can still simplify even further. So we're going to have 1/3 the integral of, so we're trying to simplify it in basic terms. So cosine 1 over cosine theta, then divide by sine theta all over cosine theta. So d theta. So we can cancel out 1 cosine, di ba? So if naglibog mo why we can eliminate the cosine theta, so try to divide it on yourself in an extra sheet of paper for you to verify that the answer is 1/3 integral of 1 over sine theta d theta, which leads us to 1/3 integral of cosecant theta d theta. Okay, so for the answer for this one, so if you don't know the integral, so that ang integral niya is negative, di ba? Negative, sakto ba? So let's try to verify. Kaya ako nakalimut sa go. Okay, so integral of cosecant, so that will be negative ln of cosecant x theta plus cotangent theta plus c. Okay, so let's try to continue it on the next slide. So again, that's negative 1/3 ln of cosecant theta minus plus cotangent theta plus c. So again, we're going to base the replacement of your cosecant theta and cotangent theta with the right triangle. Okay, so again, since we are utilizing the tangent function as per the previous slide, so notice that this one is muna siya, di ba? So x, and then 3, and then square root of 9 plus x squared. So starting with the cosecant function, so that's the opposites, the hypotenuse all over the opposite side. So this one is x all over the balide. So this one is the square root of 9 plus x squared all over x. So that's hypotenuse all over the adjacent side. So cotangent function, that's the opposite side all over, the adjacent side all over the opposite side. So that's 3 all over x. So we have negative 1/3 ln of square root of 9 plus x squared all over x minus 3 all over x plus c. So you can combine the numerator since we have the same term in the denominator. So the final answer is negative 1/3 ln of square root of 9 plus x squared minus 3 all over x plus c. So this is your final answer. So questions or clarifications? Kanin siya, plus niya, plus. Sorry. So, kanin siya, plus niya, plus. Okay, so thank you for that one. Okay, so any questions? Any further questions before we proceed to the next example? Okay, so I think there's no question. So let's proceed with the next. Okay, so we have this formula, equation. So integral of square root of x squared minus 25 over x dx. So notice that it's very far from the inverse trig function, but looking at the radical expression, so it's in the format of u squared minus a squared. So let's try to, okay, so u squared minus a squared. Again, as per formula, that's u is equal to a secant theta. Okay, so this will be our u squared. This will be our a squared. So as long as it follows the format. So again, your u squared is equal to x squared. Then your u parameter is x. So for a squared, that's 25. Then getting the square root, our a is 5. So now we can use the formula. So we have x is equal to 5 secant theta. So getting the derivative, so dx is equal to 5. So derivative of secant is unsa man? So derivative of secant is sectan sec theta tangent theta d theta. Sakto, di ba? Because the derivative of tangent is secant squared. Okay, so notice in the given equation above, so we can replace now the x with 5 secant theta. We can also replace dx with 5 secant theta tangent theta d theta. So if naglibog mo, so let's try to point it with the arrow. So exhibition lang sa ta. Okay, so what's left for us to replace is the radical expression, the square root of x squared minus 25. So again, how can we replace that one? Is again first by drawing the right triangle. So theta, di ba? So again, as per formula, so if you want to really go to the basic concept, so secant theta is equal to x all over 5. So again, the definition of secant is hypotenuse all over the adjacent side. So hypotenuse here is the x parameter. The adjacent side is 5. Then getting the other side using Pythagorean theorem, so the hypotenuse minus one leg, which is 5 squared, that's minus 25. So again, we pair up your radical expression with a constant and get its particular trigonometric function, basic trigonometric function. So as you can see, we can utilize the tangent function. So tangent theta is equal to the opposite side, which is x squared minus 25 all over 5. So isolating the radical expression, so we have 5 tangent theta is equal to the square root of x squared minus 25. So we can replace this one with 5 tangent theta. So every term now in your equation can now be replaced with a certain theta function. Alright, so starting off with the square root term. So again, that's 5 tangent theta. Okay, so 5 tangent theta. So all over the x function, which is this one here. So ato yung circle na tanan para di mo masaag, di ba? 5 secant theta. And then your dx is this term here. So times 5 secant theta tangent theta d theta. So 5 secant theta can be eliminated. So what's left in the equation is 5. So integral of 5 tangent squared theta d theta. Okay, so what's next is we can get the 5 outside the equation. So 5 integral of tangent squared theta d theta. Okay, so if you don't know or if you've forgotten how to integrate tangent squared, so this is type B. I think it's case 2 siguro to, or case 1. So we replace this one with its corresponding katong Pythagorean identity. So again, the formula for the tangent Pythagorean formula is 1 plus tangent theta squared is equal to secant squared theta, di ba? Then isolating your tangent is this becomes tangent squared theta is equal to secant squared theta minus 1. So this becomes secant squared theta minus 1 d theta. Di ba? So integrating the terms and distributing 5 to each integral. So looking at the first formula, diba? So it can be integrated because the integral of secant squared is tangent theta. So this one is 5 tangent theta. So the integral of d theta, so this is 5 theta only plus c. All right. Okay, so how can we get your tangent theta? So again, going back to the triangle. So tangent theta, so if you look at the process, so jackpot na po, di ba? Kay we have tangent theta also here. So muna siyang value sa tangent theta. So we won't have to determine again, di ba? The tangent theta function. So how about for the theta? So how do we obtain theta? So we can obtain theta by using the formula. So again, the formula is u is equal to a secant theta, which we have as x is equal to 5 secant theta. Then isolating your secant, this becomes this term here, di ba? So ato lang siyang ipadayon by getting or by isolating the secant function. So this becomes theta, and this one is arc secant, di ba? X all over 5. Diba? Ano naman na pag-determine sa angle, diba? If we're going to isolate the angle. So we're going to get the inverse function for this one. Okay. So since we now have your theta function, so the final answer is 5 times the square root of x squared minus 25 all over 5 minus 5. Then this one is arc secant x all over 5 plus c. So eliminating 5, so the final answer is the square root of x squared minus 25 minus 5 arc secant x over 5 plus c. So this is how a advanced technique looks like. So you're using the process of the new technique, the advanced technique, but you will still be utilizing the basic process such as katong mga three different types of the integrals, di ba? Katong type A, type B, type C. So magamit kaya po siya. So muna magkataas ang solution because you are incorporating the other basic concepts in the advanced technique. Alright, so questions or clarifications or naglibog na no? Basta I suggest that you try solving it again, then just learn the blue part first because I think the red part is more on the integration techniques na process. So kaning blue part is more on the trigonometric substitution process first. Yeah, after achieving the format, so the red part is more on the integral process. So you're going to use this formula, that technique, this technique, and so on and so forth. So usually in the trigonometric substitution na method, so you will be utilizing the trigonometric integrals. So katong basic formula, then katong type A, B, and C. So muna siya yung ma-encounter in these problems. Alright. So questions? So I think there's no question. So let's proceed. So nato yung continuation because I was expecting maabot og next slide. So masigo this yeah. Okay, so this time is we have the integral of 1 over x times square root of 4x squared plus 9 with respect to x. So again, looking at the formula, so you cannot achieve this one using the inverse trigonometric functions, especially that your a squared plus u squared is being enclosed in a radical symbol. So we have to utilize the trig sub technique. So we have a squared plus u squared is equal to, so u is equal to a, di siya signed but tangent, so sorry. A tangent theta. So notice that 4x squared is not a squared, but this one is u squared. So pwede siya mabali-bali because of the commutative property of addition. So 9 is a squared. Alright, so determining a first. So a squared is equal to 9. Then a is equal to 3. So u squared is equal to 4x squared. Your u parameter is 2x. So again, using the formula, so we now have 2x is equivalent to 3 tangent theta. So since the variable in the given equation is only in terms of x, so we isolate x by dividing the whole term by 2. So x is equal to 3 halves tangent theta. So we can now get its derivative. So dx is equal to 3 halves. So again, the derivative of tangent theta is secant squared theta d theta. So notice we can replace dx. We can now replace x. So again, magbutang tag arrow para malibog sa mot, di ba? Idagan na kay arrow. So here. Okay. So next is for us to create the right triangle. So theta. So again, as per formula, tangent theta. So isolating this one. So tangent theta is equal to 2x all over 3. So again, this one is opposite side. This one is adjacent side of the triangle with respect to the angle theta. So this one is opposite side 2x. This one is 3. Okay. So the hypotenuse, as per Pythagorean theorem, that's the square of the sum of the square of the two sides. So 3 squared, that's 9. Or let's say, let's follow the format. So 4x squared plus 9. Okay. So after getting the radical expression, so again, pair it up with the constant. Then after pairing it up, so determine the basic trigonometric function for this pair up. So this will be cosine is equal to adjacent side, that's 3, all over the hypotenuse. So 4x squared plus 9. So since we're trying to replace the square root of 4x squared plus 9, so we're going to isolate 4x squared plus 9. So square root of 4x squared plus 9 is equal to 3 all over cosine theta. Or this can also be represented as 3 secant theta. Okay, so we can now replace this one with, so ato ay paagi sa left kay para natay space sa right side na. Okay, so since we can now replace every term in the equation, so let's proceed with the integral process. So starting with dx, so that's 3 halves secant squared theta d theta. So next is the x parameter. So 3 halves tangent theta. Diba? And lastly is you have your 3 secant theta. So cancel out 3 halves, cancel out 1 secant. So murag the same ni siya ganina, di ba? So what's left in the equation is secant theta d theta all over 3 tangent theta. So I think this one is the same as earlier. So we have secant theta d theta all over tangent theta. So if you try to simplify it even further, so this becomes 1 all over cosine theta all over sine theta cosine theta d theta. So it simplifies into 1/3 integral of 1 all over sine theta d theta, or that's 1/3 integral of cosecant theta d theta. So again, that's 1/3 then times the integral of cosecant theta, that's negative ln, diba? Negative ln of cosecant theta plus cotangent theta plus c. So we have negative 1/3 ln of cosecant theta plus cotangent theta plus c. So bringing back the value of your cosine and cotangent. So since empty space and picking aside if we try to go to the next slide. So ako lang na yung shortcut kamaya. So cosecant is so that's square root of 4x squared plus 9 all over 2x, sakto ba? And then plus cotangent, that's adjacent over the opposite side. 3x, sakop save tayo. So that's 3 all over 2x plus c. So the final answer, so let's try to ato lang isumpay dire. So plus 3 all over 2x. So this is the final answer. All right. So questions? Okay, so no question. So antas-antas lang gamay, hapit na. So let's proceed with the second to the last equation. Na para nyo ma-appreciate ang problem. Okay, so in the equation, so it's almost safe to say that you can use the arcsecant inverse trig function, but looking at the outer part of the radical expression, that's x squared. Yan, sa atong formula sa atong inverse secant is 1 all over u times square root of u squared minus a squared. So we cannot utilize this one. So we have to go to the advanced technique. Okay, so that's the square root of u squared minus a squared is equal to u is equal to a secant theta. So our u squared is x squared. Our 4 is a squared. So u squared is equal to x squared, and then u is equal to x. A squared is equal to 4, and then a is equal to 2. So utilizing the formula, so you have x is equal to 2 secant theta. So again, getting the derivative, so you have dx is equal to 2 secant theta tangent theta d theta. So we can replace your x squared with the x here, which becomes 2 secant theta squared, diba? Then dx here is your 2 secant theta tangent theta d theta. So balik-balik na ang procedure. So mas may nang balik-balik para inyo ma-internalize. So next is right triangle na sad. So again, as per formula, so secant theta is equal to x all over 2. So definition of secant is, this one is your hypotenuse, this one is your adjacent side. So this one is the x side, this one is the two, so adjacent side and hypotenuse, diba? So obviously this one is by means of Pythagorean theorem, x squared minus 4. So again, you have to pair this up with the constant. So looking at the pair up, so we can use the basic trig function of tangent. So that's square root of x squared minus 4 all over 2. So isolating your square root function, so you have 2 tangent theta is equivalent to square root of x squared minus 4. So notice that this term here is 2 tangent theta. So once you get the hang of this, magdali-dali lang siya. Okay, balik-balik lang ang procedure leading up to the integral process. So the integral of, again, dx is 2 secant theta tangent theta d theta. So again, this one is this term here. So x squared, so since we have x here as 2 secant theta, so we can have it as 2 secant theta squared, diba? And then lastly is our tangent, this one here, square root of x squared minus 4, which is 2 tangent theta. So cancel out tangent, cancel out tangent, cancel out 1 secant. So di na pa secant 3, di ba? Cancel out 2, cancel out 2. So what's left here is the integral of d theta. Then we have 4 secant theta na lang. Then 1 over secant is, di ba? This is equal to, so 1/4 the integral of cosine theta d theta. Sakto, di ba? So since this one is super basic, so the answer is 1/4 sine theta plus c. So again, looking back at our given triangle earlier, so sine theta, so opposite side is square root of x squared minus 4. Hypotenuse is x, di ba? So may siya to ang sine function. So the answer is 1/4 times, so ato lang ikuha na. Step by step lang kay para makita. So basin mo tanan mo ano 4 siya because ang squared is sakay pa sa 2, di ba? Muna 4 siya. Ang secant is isa na lang kabuk because we canceled out 1 secant above, ba? So this one is 1/4 times square root of x squared minus 4 all over x plus c. So final answer is square root of x squared minus 4 all over 4x plus c. So this is the final answer. Okay. So questions before we proceed with the last example. Okay, so I think there's no question. So let's go to the last. So I think last. Okay, so let's go to the last example. So, so in this example, if we try to determine the counterpart, I mean the radical term for this expression, so this is dx all over. So notice the index is 2, the denominator, so that's square root of x squared plus 1, then cube, di ba? So we can eliminate 1, di ba? One term inside the radical expression because this can be represented as so dx all over the square root of x squared plus 1 squared, then x plus 1, di ba? So we can have this expression as dx all over x squared plus 1, di ba? Then the square root of x squared plus 1. Okay, so this time is we now determine the particular trig sub we're going to use. So since that's in the format of a squared plus u squared, so again that's a squared plus u squared. So we're going to, so ato lang siyang ianadana. Okay, para di siya mawalabang sa pikas ang red. So that's u is equal to a tangent theta. So a squared is equal to 1, a is 1, then u squared is equal to x squared, then u is equal to x. So by formula, we have x is equal to tangent theta lang, di ba? So it's weird for us to place 1. So derivative is dx is equal to secant squared theta d theta. Okay, so we can replace dx with, dx with this term here. Banya kaning x squared plus 1, so let's try to determine later if we can replace it with a whole term or basin dili siguro. So let's try lang later. So let's try achieving first the triangle. So theta, so again, coming from here is we have tangent theta is equal to x all over 1. Diba? X and then 1. So this one is square root of x squared plus 1. Okay? So next is we pair up this one with a certain constant, and the particular function for this one is cosine. Cosine theta is equal to 1 all over the square root of x squared plus 1. Okay, so isolating the term here, so you have square root of x squared plus 1 is equal to 1 all over cosine theta. Or we can represent this one as secant theta. So this is square root of x squared plus 1. So square root of x squared plus 1 can be represented as secant theta. So how about for the denominator kaning x squared plus 1? So notice that we have square root of x squared plus 1 is equal to secant theta. So we can get the square of this one. So you might be thinking, ako lang ibutang x dire, di ba? X, and then we have tangent square theta plus 1. So, pwede rin yapon siya, di ba? But it also leads up to the second function. So, ako ang ipakita ninyo ano. So, if we try to square this one, so we have x squared plus 1 is equivalent to secant squared theta. So, I think this one is much easier because we can replace the whole term here with secant squared theta. So, if you want to replace it using this term here, so akong i-arrowg dako. So, what we're going to have is we're going to have tangent squared theta plus 1, di ba? Then notice that this term here is a Pythagorean identity, di ba? Again, coming from the previous slides. So tangent squared theta is equal to secant squared theta. So this one, this term here can be represented by secant squared theta gyapon, which is true na atong i-verify ganina, di ba? So again, magdepende lang ninyo if unsa inyong style, basta as long as you can achieve the same final result. So this could be another method, di ba? But sa ako is, ako lang utilize nga, since if upon elimination of the radical expression, so I can have x squared plus 1 as one big term, which is secant squared theta. So I hope nakasabot ra mo. If nakasabot kay, i-try lang jud og solve on your own. Okay, so starting with dx. So that's secant squared theta, d theta, divided by, so that's x plus 1, that's secant squared theta. And then the radical expression is, so again, x squared plus 1. Then the radical expression is secant theta. So secant theta. So cancel is you have the integral of d theta all over secant theta. So in simple terms, this is cosine theta d theta. And integral for this one is sine theta plus c. So again, coming from the triangle here, so sine theta is equal to opposite side, that's the x parameter. The hypotenuse is square root of x squared plus 1. So the final answer is x all over the square root of x squared plus 1 plus c. So usually, since we don't want any radical expressions in the denominator, so by rationalization, so the final answer is square root of x squared plus 1 all over x squared plus 1 plus c. Okay, so that's the final answer. So questions or clarifications? So what are questions? So if there's no question, so I'll be uploading the problem set for this topic. And ako lang iset ang deadline in such a point that you can finish the 10 problems by that particular time. So ako sa una-una, okay, there are still other topics to discuss, to be discussed.